3, 2, 1, it's going. All right, so area between the curves. I'm going to do some general cases just to show you what's going on. So what do you know so far? And notice I am using, yes, grid paper. You should use graph paper too. I don't need graph paper, but y'all do. All right, suppose I have one curve. It's f of x, and it's a parabola that opens downward. Okay, that's a really hideous one. I need a better than that. That's f of x. And then I have another curve, g of x. Same y-intercept. This is g of x. It opens upwards. It's kind of hideous. Oh, that's really hideous. I got to do better than that. I could draw a better parabola than that. There we go. That's better. So I have two parabolas. You know how to find the area of both of them. If I tell you what to integrate from and to, do we agree? Yes. That you could integrate those. If you wanted to find the f of x, suppose I'm going to say that I'm going to integrate from 0, this point of intersection, which is 0, and I'm going to go to this point of intersection, which we're going to call, right there, we're going to call that b. This is going to be our a. So we're going to integrate from a to b, right? And we're going to do it for those points of intersection. Could I easily find the area under f of x between f of x and the x-axis, right? I could easily find that, couldn't I? It would just be this area, wouldn't it? And how do we find that area? That would be the integral from a to b of f of x dx. Agreed? Yep. And then could I find the area under the curve for g of x? Yeah. That would be this area. Yeah. And if I find that area, is that the integral from a to b of g of x dx? And if I want to find the area between them, that'd be this area. Would I just subtract those areas? Yeah. And can I make sure that I'm always positive if I find them both and I subtract the smaller one from the bigger one? But if you don't know what they look like, how are you going to know which one's smaller and which one's bigger? You would have to integrate it and see. Is there an easier way? And I'm about to show you, okay? There's an easy way to set these up to make sure you always get a positive answer and it's always appropriate, the right size. And it's simplifying to make sure you don't make silly mistakes. Because basically, if I want the area between, then I'm going to do the big one minus the little one, right? Well, so first off, you'll notice that I want to find, I'm trying to find, I need a different color. I'm going to do this one. Notice I'm trying to find this. If I'm looking at area and I'm looking at Riemann sums, see the green ones? Is that the length of my rectangles? Remember, I'm going to do an infinite number of these. Do you see what they're between? Are they between the curves? If you want to make sure a number is positive, if you always subtract the smaller number from the bigger number, will you get a positive number? When I say bigger, I mean most positive. So if we take the most positive number, which in this case, is that this curve? Is that the most positive? And for every single one of those rectangles in there for Riemann sum, is that the most positive value? And is g of x the most negative value? The lowest? If I always subtract upper minus lower, will I always get positive? So what we do is we pick a representative cross-section. We're going to call this our length. And we're always going to do, hang on, I'm going to need to make more room than that. That's some length, and that length, and that's the length of our rectangle from before. That length is the upper minus the lower. Every time. If you always do upper minus lower, in our case, what's our length? Our length is equal to the upper curve, which is f of x, minus the lower curve, which is g of x. If we keep it that way, if we always do upper minus lower, we're guaranteed to get a positive length. If we integrate that from a to b, and we always go from left to right, we're guaranteed to get a positive area. What?
If you didn't get a positive area, can you just flip it? Right?
Okay, if you just flip your answer at the end, I will take off points because you set it up wrong. Why am I going to do that? Because is this going to build? I'm teaching you this technique now for area. Are you going to use it for volume by known cross sections and volume of revolution? If you learn to do this now, you won't make mistakes when the problems get more complicated. And just trust me on this, you'll mess it up later. And the other reason we're doing this is because you need to be able to see this region here. Eventually I'm going to take you and make you spin it around the x-axis and spin it around the y-axis to produce solids. If you don't see this now, you won't see what the outer radius is and the inner radius is. Just let me get there. I teach it so it all builds. Do it right. I know if you get a negative area, go back and fix it. Don't just make it positive because you know it's positive. Go back and fix your work, because eventually these will become complicated enough that you're going to mess it up because you didn't do it right to begin with. Got it? Seriously, when we do volumes of revolution, your heads are going to spin. Okay, so it's always upper minus lower if we're doing, now notice, are my cross sections perpendicular to the x-axis? Are my rectangles, the rectangles for my Riemann sum, are they perpendicular to the x-axis? Yeah. So I'm doing everything in terms of x. It's perpendicular to the x-axis. It's upper minus lower. Everything's in terms of x. So that's just the generic on how this stuff works. Now, how did I pick A and B? I picked A and B because when I have curves that cross, when they intersect, there's a region between them. The hardest part for y'all is seeing what's between. One of the things we have to always find is points of intersection. So one of the keys here was finding the points of intersection. Algebra 2. Right? Points of intersection, you want to find when f of x equals g of x. And you're going to solve for A and B. And that's going to be our limits of integration. Now, not everything is that simple. That's a nice easy one. They intersect. It's obvious to see. Not always so much. Because we don't give you the graphs, we give you words. Oh, you're going to have to read. So what if I say, this is another just generic. What if I say find the area between f of x, g of x, x equal to some c value, and x equal to some d value. Uh-oh. Ruh-roh. What? Suppose that, so f of x is a quadratic, a negative quadratic, g of x is a negative cubic, and c and d are constants. What would that look like? So I'm going to draw you a generic one. So I have f of x. There's my f of x. I have g of x is some negative cubic. I have some x sub c value. That's a vertical line. And then I have x sub d. What is the area between f of x, g of x, x equals c, and x equals d? Do you see it? Half the battle for some of you is going to be just seeing this. Do y'all see that this region right here is between all four things? If it's four things, as long as they don't cross, because can I take four things and make a bow tie? Yes, I can. Y'all are going to see that one eventually. Do you see that region? X equals c is the left boundary, x equals d is the right boundary, f of x is the upper boundary, g of x is the lower boundary. Does everyone see it? So when we go to draw our representative cross section, like right here, do you see that that length is equal to f of x minus g of x? It's the upper minus lower, yeah? What are my limits of integration going to be? It's not points of intersection this time. If I'm integrating and my lengths are y values, they're function values, my delta x's, they're delta x's, so what am I going to integrate from and to?
From C to D.
To c to d, right? So what's this area going to be? This area is going to be the integral from c to d of f of x minus g of x dx. This is how simple you can make it. Or you can make this more complicated. We're going to start with my favorite two curves. You will see them on the test. I guarantee you will see them on the test. They are square root of x and x squared. One's concave up where I want it, one's concave down. Can I make a nice little region? And then can I move this all over the page and rewrite the equations, because I'm good at transformations, and y'all will not know it's the same problem moved. When you get the same answer over and over again, it means Mrs. White's been messing with you again. She just gave you the same thing, only I took the region and transformed it. I just shifted it, because shift happens a lot. Every morning. Okay, so we're going to start with my favorite curves. Favorite curves. So does that mean hint, hint, wink, wink, nod, nod? Make sure you can draw these really fast. When I say draw, sketch, you don't have to graph them. I'll show you how to do more complicated ones. So you just need a sketch. These are my favorite curves. Know them. Or else. So y equals square root of x and y equals x squared. And I am going to integrate between their points of intersection. You should know them. Go ahead, set them equal to each other, but it's totally unnecessary. Go ahead and do it on your own. And then I'm just going to I'm going to laugh at you because they intersect at 0 and 1. Right? 0 and 1 are the only points that make those two intersect. Let's think about this. When I put 0 into x, I get 0 for both of them. If I put 1 in for x, do I get 1 for both of them? So I'm going to exaggerate the wazoo out of my scale. Make that 1 and make that 1. So this is my point of intersection. So I'm going to make this one red. I'm going to make this one blue. So square root of x, do we all know what the square root of x, the square root looks like? It's a sideways parabola. It's the upper arm. So literally, you're just going to make it look, oops, I'm doing the wrong one. Red. There we go. You're just going to make it look concave down, right? Does that look like y equals square root of x? It doesn't have to be perfect. And please exaggerate it. Make it really concave down. We're going to make x squared concave up, and I'm going to exaggerate it. Why? Because I want to see this little region in between. If you draw an itty-bitty drawing like this, that does like this, you can't label anything. You can't see anything. And even if you could, I can't read it. Make a nice big drawing. Here's why. On your test, I will give you points if you will sketch the region, if you will label. Okay, what's the important thing here? I need to know that length. That length. This length right here, from the upper to the lower. I need to know that. So I got all this region, right? Is this the region between them? If I want the area between those, is that what I'm looking for? So do I need to know this length right here? What is that length equal to? Which is the upper curve? Which is the lower curve? If you will integrate that, you will get a positive area. You will not make a silly mistake. You will not have to go back, and you can move on to the next easy problem on my test. If not, go fix your mistake or lose points. Because the answer is not so important. What's important is all the calculus. If you didn't set up the calculus problem to begin with, you're not going to get any points. Or not much. All right, I have my length. Do I have my limits of integration if this is 0 and this is 1? Right? So what's the area between those curves? The area is the integral from 0 to 1 of square root of x minus x dx. I want to rewrite that so I can actually integrate it. Well, I can, but I need y'all to be able to. So is that the half power? Oh, squared, yeah. Doing it between square root of x and x, that's going to happen too. That's going to be a problem. So what is the antiderivative of x to the 1/2 power? X to the 3/2 divided by 3/2, same as 2/3, yes. And then what is the antiderivative of x squared? X cubed over 3, yeah. All evaluated from 0 to 1. Is that going to be 2/3 minus 1/3 equals 1/3?
That was easy.
Y'all see it? Was that easy? But it's not going to be that simple. I mean, I'm starting with the easy, but am I going to take those, like I said, and I'm going to do all kinds of interesting things to them, right? Right. So let's do another example, and then y'all are going to work. All right. So for my next trick, how much page do I got left? I'm going to set this one up, and then we'll get going. So for my next trick, so this is example 2. Not my favorite. Well, they're quadratics. Y'all are supposed to know how to graph these, but okay. So we are going to find the area. Oops. Between. You're right. Now, can they write these a lot of different ways? Right now, I'm not changing the words much because I really don't want to deal with it. But on the AP test, will they ask it all kinds of information? Do you understand what between means and how different ways they can describe it? I don't know what words they're going to use. So I have x squared minus 4x plus 3, and g of x is equal to negative x squared plus 2x plus 3. Which one opens down and which one opens up? F of x open up and g of x opens down, so g of x is probably, but not always, the upper one, because I can do a saddle instead of the other way. What if my opening down one is lower than the other one? Do I produce a saddle? Just telling you. I could have, instead of, so this is like this, but instead of that I could also do like this, where it's like this, and the region between is like this, but I would have to give you what these are. Oh, I could do another bow kind of 4 thing. Just telling you, be prepared, practice. All right, so what's the first thing we need to know? We need to know where they intersect. I can do this, but should you do points of intersection first? So the first thing we're going to do is points of intersection. POI is points of intersection. We're going to set them equal to each other. X squared minus 4x plus 3 equals negative x squared plus 2x plus 3. And you realize, of course, I should be able to just cut y'all loose and y'all should be able to do these problems now, but we probably should review some Algebra 2 skills. Algebra 1 skills, excuse me. Do the 3's cancel out? Move everything over here. Do I get 2x squared? And then I get minus 6x. Yeah? Can I factor out a 2x? And I get x minus 3 equals 0. Where are my points of intersection? X equals 0 and x equals 3. Algebra dos. Now, if you don't know how to graph that, I'm going to show you how to quickly make a table. All right. Can I change pages now? I'm going to. So where did I get to? So let's look at this. I'm going to do an XY table. So I'm going to do f of x. Actually, I'm going to have an x f of x, which is equal to x squared minus 4x plus 3, and then I'm going to have a g, so an x, g of x, which equals negative x squared plus 2x plus 3, right? And I'm going to choose, I know that I'm going between 0 and 3. Those are the points of intersection. So I'm going to start at 0 for both of them, and I'm going to go to 3. So I'm going to go 0, 1, 2, 3. 1, 2, 3. We're doing the walls. 1, 2, 3, 1, 2, 3, 1, 2, 3. Plug in 0. Are they both at 3? If these don't match and you said those were points of intersection, go back and start over. What else should match? These should match, right? Shall we go ahead and find them? Put in a 3. 3 squared is 9. 9 minus 12 is negative 3. Negative 3 plus 3 is 0. Do the same over here. Negative 9 squared means negative 3 squared is negative 9. Plus 6 plus 3 is 0. Oh, isn't that nice? Now plug in 1. For this one, if I plug in 1, I get 1 minus 4 plus 3 is 0. For this one, if I plug in 1, I get negative 1 plus 2. That means I'm up to 1. Plus 3 is 4. Plug in 2. 4 minus 8 is negative 4, right? Plus 3 would make that negative 1. For this one, I plug in 2. That's negative 4 plus 4. That's 0 is 3. Can we graph these now really fast? Okay, here we go. Gonna graph it right here. Maybe not quite that small. And I'm gonna make mine a little bigger. That's 1, 2, 3, 1, 2, 3. Yeah? Okay, so we're gonna graph, what did I say was f of x? I'm gonna make f of x blue, and I'm gonna make g of x red. So for f of x, I'm going 0 is 3, that's my y-intercept. 1 is 0. 2 is negative 1, it's down here. 3 is 0. So does f of x go like this? Oh, that was really ugly at the end. Sorry. It's better if I go fast and don't go slow. F of x. For g of x, I got the same 0. I got 1 is 4, so I got to go up 1. And then 2 is 3. And then go back down. So, bloop. G of x. Does everybody see the curve? Am I talking about going between the red and the blue curve? Do y'all see my little Riemann sums? So if I want to take one representative cross-section, is this what I expect to see on your test to make sure, if you do this, you'll make sure you don't mess up, right? Do I want to find that length right there? What does that length equal? No, it's not f of x minus g of x. Look again. Is it g of x minus f of x? Do you have to pay attention? Oh, be careful. So it's going to be g of x minus f of x. And I don't have room here, so I'm going to come down here. So my length is equal to my g of x, which was the negative x squared plus 2x plus 3. Hang on. Minus, put a parentheses, because you have to distribute it to every single term. Most common mistake is to forget to distribute the negative, and you didn't get the right equation, you didn't integrate it right, nothing happened good. So what does my length equal? It's negative x squared plus 2x plus 3 minus x squared plus 4x minus 3. We already knew the 3's were going to cancel out. That's wonderful. I got a negative x squared and a negative x squared. My length is equal to 2, and it's a negative 2x squared. And then I have a 2x and a 4x, so plus 6x. Is that my length I'm going to integrate? Yep. So is that length, and then what's this right here? What's that width? The width is what? It's delta x, isn't it? Remember Riemann sums? That's delta x. So length times width. So we now, do we know our points of intersection? We already did those, right? What were they again? 0, 3 and 3, 0. That made that easy. So what is my area equal to? The integral from 0 to 3 of plus 6 dx. Is that going to be easy to integrate? Yeah. What's the antiderivative of a negative 2x squared? 2x cubed over, okay, what's the antiderivative of 6? 6x. Am I going to evaluate this from 0 to 3?
Is that not supposed to be 6x squared?
6x over 2.
Up,
squared.
up, there's an x there. So, yeah, thank you. Yes, I lost it. Good catch. Okay, going to the next page. Hang on. I'm going to copy this so that we have where we got to. We got to here. All right. Oops. Okay. Can we keep going? Of course we can. Here we go. So what does my area equal? My area equals, I'll plug in the 3 first. So negative 2, 3 cubed, write this out. I'm going to show you number sense because this is a non-calculator question. Plus, this is 3 times 3 squared, right? Agreed? Yeah? Okay, 3 cubed over 3, is that going to become 9 because I get rid of a third? So does that become a negative 18? And what is 3 cubed? 27. What's 27 minus 18? 9.
C'est simple.
Yeah. Yeah. It's that easy. Okay. Tomorrow you'll have, but I'm going to tell you specifically what your quick quiz is over. Your quick quiz is over total distance. Is that from day 1? Yes, for this chapter. Okay, tomorrow, so we're not even close to being done with area, because guess what? We don't have to do just functions. Can I do all, you know how you had to do sideways rerun sums? We're going to do sideways rerun sums. Yeah, everything's going to be in terms of y. And why am I doing this? Because there are problems that are so much easier if you will do them in terms of y. They are a hot mess. They have radicals in them. They are nasty to integrate because it takes u sub. And then if you turn it sideways, suddenly it's a parabola and it's easy. Math easy. All right, your mission is to get going. I'm gonna stop recording.